Have you ever wondered if numbers had anything in common besides both being even or odd? Today I'm going to talk about two popular methods for comparing numbers. My name is Claudia Kemp, and I first would like to talk about the greatest common divisor. The greatest common divisor, or GCD, is most commonly referred to as the greatest common factor, or GCF. You may be more familiar with this term than common divisor. One method used for finding the GCF is called the intersection of sets. This method finds the factors of two different numbers and compares the sets of these factors to find the greatest common divisor between them. A great way to visualize or visually organize this information is by using a Venn diagram like so. The factors of one number go on this side, the factors of the other go on the other side, and then the common factors of the two are in the middle, and the greatest number of the common factors would be the greatest common divisor. And here is a filled out Venn diagram, finding the greatest common divisor of 36 and 40, the factors of 36 on the left, factors of 40 on the right, and the common factors in the middle. The greatest number of these common factors is 4, so the greatest common divisor is 4. Very simple. A use of greatest common divisor would be in party planning, believe it or not, because what is a party without party favors? So for example, your party favor supplies are 24 chocolate bars and 36 yo-yos. How many party favors can you make? Well, you take the divisors or factors of 24, which are 1, 2, 3, 4, 6, 8, 12, and 24, and the divisors of 36, which are 1, 2, 3, 4, 6, 9, 12, 18, and 36. But the greatest common one between the two is 12, so you can make 12 party favors. Another reason to learn greatest common divisor is in further algebra in your math. You will use it a lot going forward in math. Another method for finding commonalities between numbers is least common multiple. Like greatest common divisor, one method of finding the least common multiple, or LCM, is called the intersection of sets. You find the multiples of two different numbers and then compare the sets of these multiples to find the smallest number that the two have in common. That's the LCM. In other words, it is the least natural number that is a multiple of both numbers. There's some examples here on the left, multiples of 3 and multiples of 5. Multiples of 3 are 3, 6, 9, 12, 15, 18, and so on. And multiples of 5 are 5, 10, 15, 20, 25, and so on. But since we're only looking for the least common one, we can stop at 15 because they both have it in common, and it's the least one they have in common. Another example are multiples of 3 and 4, which are 3, 6, 9, 12, 15, 18, and then 4 is 4, 8, 12, 16, and 20. But the least common one is 12. And a great use for learning least common multiple is when solving equations with fractions. If the denominator of the two fractions are not the same, then you would use the least common multiple to make them the same to make the equation easier to solve. Thank you so much for listening. I hope you enjoyed learning two methods for finding greatest common divisor or least common multiple. Up next is Alexis Johnson discussing a couple more methods and applications for least common multiple.
Okay, I'm going to share my screen. Have you ever wondered if there's more than one way to solve most problems? Well, I'm here to tell you that there is, and I want to explain two methods that you can actually use to solve the same kind of problems, which are least common multiple. My first one is the prime factorizations. My second one is the Euclidean algorithm, and then I will talk about some applications of the least common multiple that you can use in real life. Some questions that you may end up asking yourself during this presentation talking about prime factorization is, what is a prime factor? Well, the definition of a prime number is a natural number, 1, 2, 3, etc., that is divisible by exactly two natural numbers. The natural numbers that a prime number will be divisible by are 1 and itself only. Then you may wonder, what is the least common multiple? Well, the least natural number, m, that is the multiple of both a and b, is called their least common multiple, and we write this as m equals LCM of a and b. So I want to do an example. So let's begin with 270 and 630. So with prime factorization, you would end up doing sort of like a factor tree. We're pretty familiar with these already. So what is the prime factorization of 270? Well, 270 breaks down to 2 and 135. You'd leave the 2 because it's prime. The 135 would break down to 3 and 45. 3 is prime, so you'd leave it. 45 would break down to 3 and 15. So the 3 is prime, you would leave it. And then you'd break down to 15. 15 would break down to 3 and 5. And those are both prime, so that would be the end of the factorization of that. With 630, the prime factorization is 630 breaks down to 2 and 315. Well, 2 is prime, so you leave it. 315 breaks down to 3 and 105. 3 is prime, so you leave it. 105 breaks down to 3 and 35. You leave the 3. 35 breaks down to 5 and 7. Those are both prime, so that is the end of that. Then you would multiply 2 times 3 times 3 times 3 times 5 and times 7. That would end up giving you the least common multiple of these two numbers, which is 1890. The next one I want to do is pretty easy and very short, actually. So what is the least common multiple of 12 and 44? Well, 12 breaks down to 2 and 6. 2 is prime, so you would leave it again. 6 breaks down to 2 and 3, and those are both prime, so you leave them. 44 breaks down to 2 and 22. 2 is prime, so you leave it. 22 will break down to 2 and 11. Well, 2 and 11 are prime. So that's the end of that factorization. So now you would multiply 2 times 2 times 3 times 11, which will give you 132. So the LCM of 12 and 44 is equal to 132. The next method I want to talk to you about is the Euclidean algorithm. What is this method? It is an efficient method for computing the greatest common divisor or least common multiple of two numbers. The largest number that divides both of them without leaving a remainder. It is named after the ancient Greek mathematician Euclid, who first described it in his Elements. We're going to do the same, this is the same question, but we'll work it out a lot differently. 270 and 630, we're going to find the LCM. So you would get the larger number, and you would equal it to the smaller number. So 630 is equal to 270 times Q, which would be how many times it goes into 630, plus the remainder. So it would be 630 is equal to 270 times 2 plus 90. So now you would move your I messed up right here. You would move your 270, that should be 270, and equal it to 90. So it would multiply 90 times 2 plus 80. 80 is your remainder, so you move it over here, and then you move 90 back over to this way. 80 times 1 plus 10 is equal to 90, so that means you're done here. You found the greatest common divisor. So the formula you would end up using here is 270 times 630 divided by the greatest common divisor. And that would end up giving you the least common multiple of 1,890 again. An application of the least common multiple. You go out to the grocery store to buy hot dogs and buns for a hot dog party you're hosting. Unfortunately, sausages come in a pack of 6 and buns in a pack of 8. What is the least number of hot dogs and buns you need to buy in order to make sure you are not left with a surplus of either hot dogs or buns? The answer is, what is the LCM of 6 and 8, which is 24 for obvious reasons. You would buy 4 packs of hot dogs and 3 of buns. There would be a lot of similar examples where you have to pair up objects and packages sizes are different. You don't want any wastages. We hope you enjoyed this presentation covering least common multiple and greatest common divisors. I hope you realize that math is all around us, whether we see it clearly or not. In order to be successful in our teaching careers, we should fluently understand all of these concepts. Thank you.